The universe is a vast dark ocean, dotted with islands of light, galaxies, stars and planets. Yet beyond these familiar shores, the cosmos hides deeper mysteries. Among the strangest is the concept of a white hole. We know black holes, regions where gravity traps everything, even light. But what if the universe has an opposite, a place where nothing can enter, only escape? This is the white hole, a theoretical fountain of matter and energy, forever expelling, never consuming. Unlike black holes, which imprison, white holes repel. They exist as mathematical solutions in Einstein's equations, haunting the edge of our understanding. Imagine a cosmic spring, wound tight, suddenly releasing its energy outward. If real white holes would rewrite our ideas about beginnings and endings in the universe. To understand them, we must push the limits of physics, grappling with gravity, singularities, and the birth of the cosmos. The story of white holes is not just about strange objects, but about our relentless quest to understand the universe. Each new mystery is an invitation to wonder. The white hole is one of the universe's most profound riddles. It challenges us to read deeper into the cosmic book, and so our journey begins. To grasp white holes, start with their twin, the black hole. Black holes are cosmic traps, regions where gravity is so strong nothing escapes past the event horizon. Now, reverse time. Imagine matter and energy erupting outward from a singularity never to return. That's a white hole, a one-way door but leading out. Nothing can enter, everything is expelled. White holes and black holes are mathematical opposites, both born from Einstein's equations. One devours, the other gives. If you approached a white hole, you'd be pushed away by an overwhelming force. From afar, it would shine blindingly bright, constantly emitting matter and radiation. But its event horizon is impenetrable. No entry, only exit. White holes are fortresses forever expelling their secrets. They are the ultimate cosmic source, while black holes are the ultimate sink, two sides of the same cosmic coin. White holes emerge from Einstein's general relativity, the same theory that predicts black holes. The Schwarzschild solution describes both. A black hole's event horizon traps, a white hole's expels. For a white hole, the event horizon is a one-way surface. Matter and light can only leave, never return. At its heart is a singularity, but unlike a black hole's future singularity, a white hole's is in the past. All its matter and energy erupt from this single point. But where did it come from? The math says it was always there, a troubling idea for physicists. The biggest problem, stability. Even a single photon approaching a white hole would trigger its collapse into a black hole. This instability makes white holes unlikely to exist in our universe. Despite being mathematically possible, they seem physically forbidden. White holes remain theoretical, their existence challenged by the laws of nature, yet they push us to question what's truly possible. If white holes exist, they should be spectacular explosions of matter and energy. Some once thought quasars or gamma-ray bursts might be white holes. But we now know quasars are powered by supermassive black holes, and gamma-ray bursts come from collapsing stars or neutron-star collisions. A 2006 gamma-ray burst sparked speculation, but no conclusive link to white holes was found. Every strange cosmic signal has found a conventional explanation. Today, there is zero direct evidence for white holes. We photographed black holes and detected their gravitational waves. But white holes remain mathematical phantoms. They haunt our equations, but not our telescopes. The search continues, but so far white holes are only beautiful ideas. Why haven't we found white holes? The answer lies in physics. Black holes form naturally from collapsing stars, a one-way process. But a white hole would require the universe to run backward, violating the second law of thermodynamics. Entropy always increases. Shattered glass doesn't reassemble, and stars don't unburn. A white hole would mean a spontaneous decrease in entropy, something nature forbids. Even if one formed, it would be instantly destabilized by incoming energy, collapsing into a black hole. The universe seems to prevent white holes from existing. Some speculate white holes might have existed only at the universe's birth. Perhaps the Big Bang itself was a kind of white hole, a single eruption of everything. In this view, we live inside the aftermath of the only white hole that ever mattered. White holes may be relics of cosmic origins, not objects scattered across the sky. Their mystery connects to the deepest questions of where we come from, and why the universe is the way it is. If white holes are so unlikely, why study them? Because their existence in Einstein's equations shows our understanding is incomplete. White holes force us to confront the clash between general relativity and quantum mechanics. At their core lies a singularity where physics breaks down. Some theories suggest black holes might bounce and become white holes, connecting universes or forming wormholes. These ideas, though speculative, push the boundaries of science and imagination. Studying white holes tests our theories to the limit. We must either explain why they can't exist or search for evidence. This process is the heart of science. Even if white holes are fantasy, the quest to understand them teaches us about the universe. Our journey has taken us from black holes to their mysterious opposites. White holes remain mathematical possibilities, but nature seems to forbid them. Every cosmic mystery once linked to white holes has found a simpler explanation. Yet the questions they raise about time, entropy, and the universe's birth remain profound. Perhaps black holes are not endpoints, but beginnings. Perhaps information is not lost, but reborn. White holes challenge us to imagine, to calculate, to search. They remind us that the universe's map is still unfinished. Our curiosity drives us to explore even the impossible. The greatest discoveries may still lie in the blank spaces of our cosmic story.